Welcome, folks. Hopefully, you're staying warm on this cold, icy day. This video is in lieu of the class. I'm going to go through the test completely, so you have the whole video in case you missed last class. But if not, skip to where I worked through the problem 8 or 9. All right, starting with the first problem. So what you see here is read and report a graduated cylinder to the correct significant figures. This is both how to read a graduated cylinder and how to report something that you can measure of graduated cylinder. The idea is to measure to the nearest line and then take it one step past to what's called the estimation place. So on this graph, you can see here's 4 mils. Here's 5 mils. 4.1, 4.2, kind of hard to see, but 4.3, 4.4, 4.5. So you could easily say you, as the water, you want to measure the bottom of the meniscus. So it's between 4.2 and 4.3. So the estimation place is this second decimal place. So we're going to estimate to the best of our ability. Maybe we'll say it's 4.23 mils. You don't have to be exact on there because it is an estimation. You should be somewhat close, but there can be some room for disagreement. There is no disagreement that it's 4.2 something, but there should be no disagreement that it's 4. But there might be some disagreement that it's 4.23. Liquid nitrogen boils at negative 320.44 Fahrenheit. What is the temperature in Kelvin? So we are going to turn Fahrenheit into Kelvin. The two equations are Fahrenheit equals 9 over 5 C plus 32 and C plus 273 equals Kelvin. Now, before you're like, wow, that's amazing, he knows those equations. What am I supposed to do? Well, on the useful information sheet, the last page, all those equations are there. Quick, just jumping right there. So you see here, periodic table. Moving up, there's some conversions. And here's my equations. Doom and doom. So you don't have to memorize those. Those are going to be given to you, but you still have to know how to use them. Step 1. So we have negative 320.44 here. So first step, I have to subtract 32. Then whatever I do to that, then I have to multiply by 5 over 9 to give us Celsius. Negative 320 minus 32 is 352 times 5 over 9 gives us, we'll say, negative 196. That's probably safe. Now, negative 196, we add that to 273, and that should give you a number. Well, at least close your answer. 77.4. 77. So A. Now determine the proton, neutron, electron count. The proton is equal to atomic number. We have the atomic mass, and we have the charge. That's what we're given. So we need to find the proton, neutron, and electron count. So the atomic mass is just the atomic number is just the proton count. Atomic mass is proton plus the neutrons, and the charge is protons minus electrons. Atomic mass, 1. Atomic number, 3. Atomic mass is 3. Atomic number 1. So 3 equals 1 plus N. So N has to be 2. Charge is negative 1. Negative 1 equals P minus E. Electrons have to be 2. Same thing here. 50. 116 equals 50 plus N, which means N has to be 66, and 4 positive. So positive 4 equals 50 minus the electrons. So we must have 46 electrons. Now, before you're like, wow, you can have a calculator. You do not have to do any of this in your head. Rutherford's gold foil experiment. So let's look at that one. Rutherford's gold foil experiment bombarded gold foil with alpha particles and captured the deflected particles on a photographic screen. What did it discover? Presence of a small, densely packed nucleus. Nope, it didn't find neutrons. It didn't determine the mass of a proton. We knew approximately the mass of the atom, but not the mass of the protons. And we already knew the charge of an electron. Finally, on the first page, what is the name of the following ion? So this is a non-metal mixed with a non-metal, and there's no ionic charge. When this is neutral and it's two non-metals and non-metals, we name it as a bimolecular covalent compound, meaning either C or B. These two are ions. So C or B. So we're left with monochlorine dioxide or chlorine dioxide. And both of them have a 2 here. But here, one of them says 1, one of them doesn't say 1. The rule is the first element is assumed to be 1. So if it's 1, you don't have to specify. If it's not 1, you do have to specify. So we're going to assume this guy's 1 unless someone says otherwise. So monochlorine is like redundant, meaning it's a duplication that can be removed without confusing anyone. Which statement is false? A theory has been proven can become a law. A hypothesis that has been thoroughly tested and supported by evidence can become a theory. An observation that is always seen to be true under a specific set of circumstances is a law. And the hypothesis and theories provide explanations for observations and laws. Well, hypothesis, while not proven yet, strives to find an explanation for observation. A theory has been usually thoroughly proven and does provide explanation. So D, no. Observation that is always seen to be true, that's the basic definition for a law. Hypothesis that has been thoroughly tested and supported can eventually become a theory. Yes, hypothetically. That leaves us with A. A theory and a law are only tangentially related. That a theory cannot be upgraded to a law. There are two approaches to the same thing. A theory explains a law, but a theory can never become a law. A theory explains the law that already existed. Now, chemical formulas. So you gotta look. So we got a metal, titanium. Because of this, it tells us titanium 4 plus. O, non-metal. O is group 6. Look on your own periodic table and test that. Because it's group 6, it wants to move to group 8. On the periodic table I've given you, it's group 16. It wants to move to group 18. So to move 2 to the right means -2. How do we compare 4 and 2? That'd be 2 and 4, which simplifies to 1 and 2. So TiO2. H, so it's an acid. That means there has to be H's associated. H is group 1. So it's always +1. Now Br, bromic, Br. Now the question is whether it's Br or versus BRO something. Which possibility do we have? Well, how do we tell? Well, the hydro right there says it's just Br. Just Br. And because Br is group 17 or 7, it wants to move 1 to the right to get to the noble gases. HBr. Magnesium, that's group 2, so it likes to be 2 plus. Chloride, group 7 or 7A or 17, so it means it wants to be 1 minus. Cross over, you have MgCl2. Barium, group 2, 2 plus. Here's our first really hard one. Sulfate. So there's ATE. Sulf tells us it's a sulfur. 8 tells us it's an oxyanion. The 8 specifically tells us it is the max oxyanion for sulfur. So it's SO4. And because SO4 is in group 16, it wants to be 2 minus. So 2 minus, 2 plus cancels out. So BaSO4. Finally, a non-metal and non-metal. Nitrogen, and there's oxygen, and the 3 tells us it's NO3. We don't care about the charges of these guys. We can figure that, we don't need to figure those out because it's a bimolecular compound. 8. An atomic weight is calculated based on the weighted average of all isotopes of an element, with boron, which would be more abundant based on the atomic weight of 10.81. So if we average all the boron 10s and all the boron 11s, which one would have to be more abundant? So the trick of it is closer to boron 11 than it is to boron 10, meaning there has to be more boron 11s than there are boron 10s. Because if it was 50-50, your mass would be 10.5. If it was 50-50, your mass would be 10.5. What is the molar mass of K2HPO3? Well, K, 39.1. There's 2 of them. H is about 1. P, that's phosphorus. It's, I think, 31. And then O, 16 times 3. So 39.1 times 2 plus 1 plus 31 plus 16 times 3 gives us 158.2. You could probably just give it as 158 and be just fine. Last problem on this page. Give an example of a physical property and of a chemical property. Physical property is something that does not change. It's like does not affect the chemical to the element to measure it. Like density is a physical property. Hardness is a physical property. Let's see. Conductance. Solubility. Chemical property is something like acidity or basicity, oxidative potential. So the ability to rust, just largely reactivity things. Combustion. How long? Decomposition. What is the temperature at which it decomposes? So certain things, you can melt sugar, but if you heat it too high, it turns into a gloopy mass, which you essentially burn the sugar. The sugar no longer serves its purpose. That would be an example of it's gone past the melting point, which is a physical property, into the decomposition point, which is more of a chemical property. A sample is added to a beaker weighing 35.078, making the total mass of 42.058. If the density is this, what is the volume delivered? So 42.058 minus 35.078. how much mass was delivered. That's the first step. 42,058 minus 35,078. You would want to report 6.980. Just because those add a zero, don't leave that out. Your calculator, stupid calculators like this one, would leave that out. But smart calculators, you can teach it to not do that. So what is the volume? 6.980 grams divided by the density 1.1132 grams in 1 mil would give us what volume? 6.980 divided by 1.1132. You're going to get a whole mess of numbers. So I'm going to write the whole mess, 6.270212001 mils. So how much do I record? Well, I have 1, 2, 3, 4 sig figs there. I have 1, 2, 3, 4, 5 sig figs there. I record 4 sig figs. 1, 2, 3, 4 sig figs. I report 6.270 mils. Got to remember, you count from the first non-zero number to the right when you have decimals. You don't leave off the back zeros. Those back zeros are significant. What is the mass percent of iron 3 oxide, well, Fe3O4? So iron, we can round judiciously on this one, so it'll be fine. Iron is about 56. Oxygen is about 16. So what is the total mass? First, 56 times 3, that is 168. 16 times 4 is 64. So 168 plus 64 is about 232. The equation for this one, percent mass, percent is equal to mass of iron over total mass times 100. So we're going to take 168 over 232 times 100. And that's going to give us our number. 168, 232 times 100 puts it at about 72.4. So B. What is the most common charge of the following elements? The easiest way to do this is look at our periodic table and count our numbers over. What is the charge of this guy? What is the charge of this guy? You're either going to the left or to the right to get to this column. So aluminum is group 3A or 13. It's easier to go 3 to the left. So this guy's typically 3 plus. N is group 15 or 5A. It's 3 to the right. Sulfur is group 16 or 6A, 2 to the right. Here's a trick question. Hydrogen is group 1. It can either go 1 to the left or 1 to the right. So it could either be 1 plus or 1 minus. It depends on what it's mixed with. Either one would have been acceptable. Either one would have been acceptable. It still got credit. How many moles of nitrogen are present in 85.2 grams of N2O? So this one's a little bit of a trick one. Not too bad, but a little bit. There's how many grams? What is the molar mass of this? Well, nitrogen is 14. There's 2, and then there's 16. So 28 plus 16 is 44 grams. So 44 grams, 1 mole of N2O. Now the trick here is for every 1 N2O, you get 2 moles of N. N2O, 2 moles of N. So you have to double the answer you get. So 85.2 divided by 44 times 2 is 3.87. So instead of getting D, which is 1.94, or instead of getting 1.94, you get 3.87. Trick C. This one is a classic one. I'm not going to give you this one, but it's something very similar. Convert the speed of light into miles per hour. So 2.998 times 10 to the 8th meters in 1 second. Well, I can do this 60 seconds in 1 minute, 60 minutes in 1 hour. I can say that there is, I'm going to use a super shortcut that I've given you guys. There is 1,000 meters in 1 kilometer. And in 1 mile, there is 1.609 kilometers. So everything on top gets multiplied. 2.998 times 10 to the 8th times 60 times 60 divided by 1,000 divided by 1.609. And I get like 6706 times 10 to the 8th miles an hour. So one trick here is remembering that meters is the small one. So there's more meters in a kilometer. You do that, that's pretty straightforward. But I could have gone meters to centimeters to inches to feet to miles, but this is a little bit shorter. So I went with that. Calculate the density of diesel if 12.45 kilograms are in 14.3 liters. Fun fact, there's 1,000 grams in a kilogram and 1,000 milliliters liter. So I can say 12.45 kilograms, 14.3 liters, and then say there is in 1 kilogram 1,000 grams, and in 1 liter there's 1,000 milliliters. Fun fact, 1,000 over 1,000 cancels out. Liters, liters, kilograms, kilograms. So it just becomes 12.45 divided by 14.3. The density of diesel fuel is something like 0.870, well, let's say 871 grams per milliliter, because 3 sig figs. Last page. Please note, on our test, we only have 16 problems, so we would have already been done. But last page. How many molecules of calcium carbonate are present in 29 grams? If I took 29 grams, I have to turn that into moles. So what is the molar mass of calcium carbonate? Calcium is something like 40. Carbon is 12. Oxygen is 16. 16 times 3. 40 plus 12 plus 16 times 3 is something like 100. 100 grams in a mole. So with that in mind, then in 1 mole, there is exactly 6022 times 10 to the 23rd molecules. So 29 divided by 100 times 6022 times 10 to the 23rd. So you get something like 1.74 times 10 to the 23rd. Give the names for the following compounds. So this one's SO4, that's sulfate. But because it's with H2, because it's only with hydrogens, it is an acid. So the A goes to IC. So that becomes sulfuric acid. This one, there's a sodium as well as a hydrogen. So it becomes sodium hydrogen And the CO3, that's carbonate. So carbonate. Even though it's with hydrogen, it's because it's with a metal, it's sodium hydrogen carbonate. As I said, non-metal, this becomes chlorine trioxide. Don't need a mono. And while this is a transition metal, it's one of these specials. See, specials. So it's normally we would say zinc 2 plus, but because it's zinc, it's just zinc. So sulfur becomes sulfide. So zinc sulfide for the full credit. 19. What is the chemical symbol that would be represented in this format? N sub X, but charge, something had 48 protons. So 48 protons, 66 neutrons, and 46 electrons. So as you said, the mass number is 48 plus 66 would be something like 114. And 48 minus 46 would be something like positive 2. So whatever the element is, how do we figure out the element? To figure out the element, we look at the periodic table. What element is 48? 48 is cadmium. So CD 114 to positive. A. What term or phrase would be used to describe a mixture that is non-uniform in composition, like oil and water? And then the difference is heterogeneous mixture. Heterogeneous mixture is non-uniform. Metalloid is a type of element. Compound is 2 elements bound together chemically. Homogeneous is uniform. What is the empirical formula? This was a hard bonus question. Sometimes I give you easy ones. Sometimes I give you hard ones. What is the empirical formula of a compound that contains 84% carbon, 16% hydrogen? So empirical formula, I just have to find the simplest whole number ratio of moles to moles. So 84 grams of carbon. Carbon weighs something like 12 grams per 1 mole. 16 grams of hydrogen. Hydrogen weighs something like 1 gram per 1 mole. 16 moles of H. 84 divided by 12 is something like 7 moles of C. What is the simplest whole number ratio of 7 and 16? Well, there isn't one. So literally the C7H16. I didn't want you to get all roundy on me. You could say 16 divided by 7, but it's not really close to a whole number. You get something like 2.28. 7 to 16, when they're whole numbers, don't question it. That is a chemical formula. That is like heptane, and that's perfectly fine. But that was the test. If you can do this test, or at least most of this test, you're probably in good shape. If you're struggling on something, start looking at the homework. Okay. Have a good day. See you in class soon.